Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at Newton Raphson's method. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing the notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Alright, so we want to first of all start by looking at an example. So assuming we are given the function s is equal to what? The root of 7. And the question demands that we use the Newton Raphson's method. Newton Raphson's method. Okay, to find the value of what? X. So how do we go about this? Now, the Newton Raphson's method has the formula xi plus 1 is equal to what? Xi minus f of what? Xi over what? F prime of Xi. Now let me explain what this means. So all that this formula means is what? The value that you are looking for, which is probably this s, is equal to some guess root, which we are going to be looking at whilst we start solving this example, and then the function f of Xi divided by what? The differential of that function f of Xi. Now let's have a look at how to use this formula to solve this particular question. So the first thing we want to do is what? Rewrite this equation. So we have s is equal to what? The root of 7. If we try to get rid of the root sign, it means what? S squared will be equal to 7. Now if we bring s to the other side of the equal to sign, we now have s squared minus 7 is equal to 0. Now this is in the form of a function. So we can say what? Let f of Xi, okay, be the function s squared minus 7. Okay, so now that we have our function f of Xi, let's now find f prime of Xi. So it means the f prime of Xi means we need to differentiate this function, and if we differentiate s squared minus 7, we get what? 2x. Right, so it means already we now have our f of Xi and then f prime of Xi. So we need what? Si, which is what? Our guess root. Now we don't know what value our guess root is going to be, so what we need to do is what? To predict the guess root. So from here we are going to what? Predict, okay, the guess root. Alright, so predicting the guess root is really easy. So we want to use this equation over here, let's say equation 1, to predict the guess root, because we don't know the value of x of I. So we say let what? X of I, okay, be equal to 1. So if this x of I is equal to 1, let's substitute that in place of the x over here. So if we have 1 squared, we know 1 squared is equal to 1, and that is less than 7. So probably 1 is not going to be a suitable guess root. Let x of I be equal to what? 2. If we have 2, then it means we substitute 2 here. We have 2 squared, that is equal to 4, and this is still less than 7. Alright, so let x of I be equal to 3. Now if x of I is equal to 3, we have what? 3 squared, and that is equal to 9, and this is greater than 7. So we get to realize that when our x is 2, we have a value that is 4, and it is less than 7. But when x is equal to 3, we have a value which is 9, and that is greater than what? 7. So this implies our what? Our guess root or our answer, okay, guess root lies, okay, between the value what? 2 and 3. Okay, so if the guess root lies between 2 and 3, it means our answer is also between what? The values 2 and 3. So because we do not know what our answer is, we can start with any number from 2. Let's say 2.1, 2.2, 2.3, 2.4. Now there is a trick here. Okay, now there's a trick that I normally use during my calculation or in an exam. Okay, and that trick is what? We know that we can use calculator to solve the root of 7. And then if you use calculator directly, this is what you're going to get. Your answer is going to be what? 2.6457. Okay, so not to waste time, what I normally do is what I select a value which is very close to 2.6 as my guess root. Okay, so it means when I substitute that guess root into this formula, okay, and I do it 2 or 3 times, then I get my final answer. Okay, so what I would do in this example is what I quickly punch the root of 7 into my calculator, and I know the answer I'm going to get is somewhere around 2.6457. So I will decide to select my guess root. Okay, so I know the answer is this. So the answer is what 2.6457. So I will say this is not inclusive. So I will say let my guess root be equal to what, any value, let's say 2.2. So I know now that I have my guess root as 2.2, I'll have to substitute this value into the Newton Raphson's equation over here to get my answer. Okay, now this is the answer I'm expecting. So until I do the substitution and I get an answer very close to this repeating, I'm not going to end the substitution. Alright, so from here we substitute 2.2 into the formula. So it becomes what? Xi plus 1 is equal to, we do the substitution, so we get 2.2, which is the x, which is the guess root over here, minus, now the function f of s is what we have over here, s squared minus 7. So we have the s is what, 2.2 squared, then minus 7 on the function f prime of s is this one that we have over here, 2s, so it's going to be 2 into brackets 2.2. Okay, all right, so if we punch everything here into the calculator, we are going to get what, 2.6909. okay, now that we have 2.6909, what we need to do is what, we need to substitute this back into the formula again and then solve again. So it means our xi plus 1 again will be equal to what, this time around is going to be 2.6909 minus into bracket 2.6909 squared minus 7 on 2 into bracket 2.6909. okay, so if I punch all of this, I compute all of this into the calculator, I'm going to get a value that is what, 2.6461. okay, already I can see I'm getting close to the answer, so I do this again. Okay, so let me do that on a new page. If I substitute that, the value I have over here, that is what, 2.6461, back into the formula again, I get what, something that looks like 2.6461 minus, then into bracket 2.6461 squared minus 7 on 2 into bracket 2.6461. So if I compute everything over here into the calculator, I get an answer 2.6457. Now if you compare this answer, okay, to what I'm expecting, you can get, I'm expecting 2.6457, and I have what, 2.6457 for the first time after computing this, after computing 2.2 first, then 2.6909, and then 2.6461. So I need to do it again to show that what, this will be the answer that will be recurring the further I go. So I do the final substitution again. So I have xi plus 1 is equal to, let me use green. Right, so that is going to be what, 2.6457 minus into bracket 2.6457 squared minus 7 all on 2 into bracket 2.6461. So if I compute this using my calculator again, I'm going to get an answer which is what, 2.6457. So now that I have this, okay, repeating twice, I can boldly say this is my answer, but I already know that is going to be my answer, so I can stop here and say therefore, okay, x, okay, is equal to what, 2.6457. so this is my answer. So if I were to input this root of 7 into calculator, I'm going to get this as my answer. So that's this does it for the first example. Let's have a look at another example to further understand this method. So we are to find s when, or the question is what, cubic root of 9. Okay, so this is just the question. So solve cubic root of 9 using the Newton Raphson's method. So first of all, we say let, okay, this function be equal to what, x. So s is equal to what, cubic root of what, 9. Okay, now if we want to get rid of the cubic sign, we cube both sides. So we have s cubed is equal to 9. So from here we can have s cubed, bring the 9 here, minus 9 to be equal to 0. So we can now say this should be the function f of x prime. Okay, so it means our function f of what, x prime or I is equal to what, s cubed minus 9. Okay, now if we differentiate this function, if we differentiate the function over here, we get what, f prime of what, xi. And that means if we differentiate s cubed, we are going to get what, 3s squared. If we differentiate 9, which is a constant, we get 0. So that does that. So already from here we have our f prime of s and then our f of xi. So all we need is what, our guess root. So first of all, the first thing we need to do is to predict our guess root. Okay, so for us to predict guess root, we are going to use this equation over here. So let me label this equals to 1. So I'm going to use that equation to predict the guess root. So now that I'm here about to predict the guess root, I'll say, okay, assuming, let's say, let s be equal to, let's say, 1. Okay, and I know 1 cube is going to give me 1. Okay, and that is less than what, 9. So I'll say let x be equal to 2. Now if s is 2, I have what, 2 cube, that is going to give me 8. It's still less than 9, but it's still less than 9, but very close to 9. So I'll say let x be 3. Okay, when s is 3, I have what, 3 cube, and that is going to give me what, 27. And this is far greater than the answer we want, which is 9. Okay, so it means my answer or my guess root, okay, so my answer lies between what, 2, because if we have 2, the answer is 8. If we have 3, the answer is 27. So the answer lies between what, 2 and 3. But look at something. If the answer is 2, if the s is 2, we get to realize that it is 8, and that is very close to 9. So that should tell us that our answer is not very far from 2. It's going to be 2.1 or 2.2 or 2.3, something very close to 2, but a bit far away from 3, because anything getting close to 3, if you cube it, it's going to give us something which is bigger than what, 9. So over here, as usual, the hint, you quickly punch this into your calculator and see what you're going to get. So if you punch cubic root of 9, or you input that into your calculator, you know you're going to get what, 2.08008 as your answer. So this is going to be your answer. So you know your answer is very close to 2. So all you need to do is what, select a guess root that is very close, okay, or around the region of 2. So for this example, I'm going to say let, but please don't include this when you are solving the question, because the lecturer is going to notice. It's just a hint. So you say let's say your guess root, let s is equal to, so I'll start with 2, be my guess root. Alright, so if this is my guess root, I can now quote the Newton Raphson's method formula, so which is xi plus 1 is equal to what, xi minus f prime of what, let me clean this. Alright, f of x on what, f prime of x. Alright, so from here I know that my xi, which is the guess root, is 2, then minus f prime of s, which is this equation over here, is what? S cubed minus 9. So I'm going to have what? 2 cubed minus 9 on f prime of s is what? 3s cubed. So I'm going to have 3. Then the s is what? 2. Sorry, this is 2. Then I square it. Remember, this is 2. Let me rewrite that. So this is 2. Alright, if I compute everything over here into the calculator, I'm going to get si plus 1 to be equal to what? 2.08333333 recurring. So I need to what? Input that back into the formula and solve until I have something close to my answer, which is the hint that I've written over here, or I have an answer recurring. So I input this into the formula again. So I have xi plus 1, that is going to be, so I have 2.0833, okay, then gonna be minus into brackets 2.0833 recurring cube minus 9, this is minus 9 negative, all on 3 into brackets 2.0833 squared. So if I compute everything here into the calculator, I'm going to get what? 2.08008. Alright, so I need to what? Input this back into the formula again and see what I get. So I have xi plus 1. Let me use another color for that. So that is going to be what? 2.08008 minus into bracket 2.08008 cube, then minus 9. Okay, so here let me put it this way, minus 9 this side on, then 3 into bracket 2.08008 squared. Alright, so that is going to give me, if I compute this, I'm going to get 2.08008 something. So I can see that my answer, this and this, is recurring. So I can say the value of x is equal to what? 2.08008. This is my answer. That is, if I input what? Cubic root of 9 into the calculator, this is what I'm going to get. Alright, let's have a look at one final example. So we are to use the Newton Raphson's method to find what? To solve the equation log. Sorry, this is log y is equal to what? 2y minus what? 6. We are to note that the differential of log of what? S is equal to what? 1 over what? 2.303 what? X. Alright, so this is our problem or our question. So let's write down our solution. Okay, so we are to use the Newton Raphson's method to solve this. So the first thing we do, as usual, we write down our equation. So we have log y is equal to what? 2y minus 6. So we need to what? Equate this to 0 as usual. So we have log y minus what? 2y plus 6 is equal to 0. So now that I have this, I can boldly say that my equation, that is what? F of xi is equal to what? Log of y minus what? 2y plus 6. Okay, so I now need to find what? F prime of what? Xi, which is what? I need to differentiate this equation over here. Now remember the note over here, say the differential of what? Log x is equal to what? 1 over 2.303x. So it means if we have, assuming for here for instance, we have log, let's say x, if I differentiate this, okay, if I apply dy dx to this or ddx to this, I'm going to get what? 1 over what? 2.303x. If it were to be, let's say, log k, and I differentiate this ddx to this, I'm going to get what? 1 over what? 2.303 what? K. That is what this scenario means. So let me quickly erase this. Right. So what that means is what? If I differentiate log y, I'm going to get what? 1 over 2.303 y. Okay, then minus, if I differentiate 2y with respect to y, I'm differentiating with respect to y, so I'm going to get 2. Okay, so it means f prime of x of I is equal to what? 1 on 2.303y minus 2. Alright, so now that I have my f of xi and then f prime of xi, all I need to do now is what? To predict the guess root. So predicting guess root. So as usual, I'm going to use an equation to predict the guess root, but for this example, I'm going to rewrite this equation over here, okay, in a more suitable way so that I can predict my guess root. So I'm going to say what? Log y minus what? 2y is equal to what? Negative 6. So I need to equate it to something. Okay, so I'll say let, okay, I'm predicting the guess root, so I'll say let let's say y be any value, let's say 2. Right, so if y is 2, I'm going to have log what? 2 minus 2 into bracket 2, and that is going to give me negative 3.6989, and this definitely is greater than negative 6. So this is greater than what? Negative 6. So I need to use another value, so I will say let y be equal to 3. So if y is 3, I'm going to have log 3 minus 2 into bracket 3, and that is going to give me, if I compute that into the calculator, I'm going to get negative 5.52288. Okay, and this is also what? Greater than what? Negative 6. But we can see that this is very close to what? Negative 6. So we are obviously going to get an answer which is very close to 5 or around 5. Right, so let's predict our next one. So we say let y be equal to 4. So if y is equal to 4, we have what? Log 4 minus 2 into bracket what? 4, and that is going to give me negative 7.3979, and this is obviously less than negative 6. So this is definitely less than what? Negative 6. So what this means is what? If my y is equal to 3, I have an answer close to negative 6. If my y is equal to 4, I have an answer which is less than negative 6. So it means my answer lies between 3 and 4. So therefore, guess root lies between what? 3 and 4. So my answer is going to be between what? 3 and 4. So all we need to do is to choose a value which is very close to 3.1 or 3.2 or 3.3, something very close to 3, and put it into the Newton Raphson's method formula, and what? Keep solving until we have what? A group of answers repeating, and we know that is going to be our answer. So let me quickly erase everything that we have over here, and then we start. Alright, so we said let our answer is going to be between what? 3 and 4. So I'm going to say let, okay, I know the answer is very close to 3, so I'm going to say let 3.1 be my guess root. So it means if I quote the formula now, because we are solving this problem in terms of y, so it means our formula is going to be yi plus 1 is equal to what? Yi minus what? F of what? Yi over f prime of what yi. It's just a matter of changing the x I to yi. Alright, so I said let my guess root be 3.1, so it means my yi plus 1 is going to be 3.1 minus. Now if you remember very well, if the f of y that we have from that equation was what, log y minus what, 2y plus 6, and then the differential was what, 1 over 2.303y minus what, 2. Okay, so it means from here we substitute 3.1 in place of the y over here, so we have yi plus 1 is going to be 3.1 minus log of what, 3.1 minus 2 into brackets 3.1 plus 6 on 1 on what, 2.303. Our y is what, 3.1, then minus 2. So if I compute this using my calculator, I'm going to get 3.2567. Alright, so let me input this back into the formula and see what I'm going to get. So let me use another color. So if I substitute this back, I'm going to get y I plus 1 is going to be what, 3.2567 minus log of what, 3.2567 minus 2 into brackets 3.2567 plus 6 all on 1 over what, 2.303 into bracket 3.2567, okay, minus 2 as in over here. So we have yi plus 1, and that is going to give us what, 3.2564. Okay, so if you look at this and this, you can see we are getting 3.256 something, 3.256 something. Now if we input this back into the formula, we are going to get something close to 3.256 something. So in the end, we get to realize that our answer, or the value of y, is going to be what, 3.256. So this is the value of y, or our answer for y. So thank you so much for watching. I hope this tutorial was helpful, and if you find it helpful, make sure you like the tutorial so that the YouTube algorithm will highly recommend our tutorial to other people that may need it. So thank you once again for watching, and I will see you in the next video. Bye bye.